So in this session, we're going to talk about query syntax. It's basically SQL, but there are some difference. And the programmatic access to BigQuery and best practice. So this session is actually a little longer, and we have a lab break in the middle, just after the query syntax. And then we have another lab at the very end. So at the end, you can still keep on working on the one in the middle. So the one in the middle is just for kind of a break. All right, so let's start with the syntax. So as we already know, this is the syntax is a variation of the SQL, but BigQuery doesn't really allow to modify the data. So the only statement you can have is select. There's no create or update or drop. If you want to drop the table, go to Web UI or use BQ. And update, we don't have any update. Create, you can create table by BQ load or from Web UI. And so this session basically, focus on difference from the standard SQL or the things you might want to be aware when you use BigQuery. So this is not meant to be your full reference. So I don't cover one by one. Does it make sense? Okay, from. So from allows subselect. Select from, select blah, blah, blah. But BigQuery output is limited to 128 megabytes total, and that's also applied to the subselect. So if your subselect statement returns bigger data than 128 megabytes, it's going to fail. And also, we discussed a little in the previous session, this from statement accepts multiple tables. So if you follow our practice and separate the table per month, the query like this, select from January, February, March, will return the data for Q1. So join, so I mentioned it's a good idea to denormalize before you ingest data. But BigQuery still supports join. And somehow we have regular join and large join. So regular join, meaning the table that's joined is less than 8 megabytes compressed. So usually it's maybe 40, 50 megabytes. And if the other side, the table that's joined is larger than 8 megabytes, what we can do is use large join. So by large join, so instead of just join, add each after the join. All other syntax is the same. So Wally, in the next session, Wally will talk about why there is a difference for the regular join and large join. So the question is about the size 8 megabytes limitation, if that's a whole total size or the one size. So the answer is the size of the table that is joined, so one table, the right side. There are only the columns that needed to be applied. So in this example, so this is the table in from is a main table, and this table too is a joined table. So in this case, the size included in this table too must be less than 8 megabytes compressed. Clear? that's columns. Yes, 8 megabytes. So the question is about the size of this. If this is if this includes entire column or the joined columns. So this is only this 8 megabytes counts only the columns that are included in this join. Yes, you can have multiple tables. Total will be less than 8 megabytes. Can the table be in different data set? I think we can, yes. So the question is if the limitation is a par select or par join, and the answer is a par join. So if you have this whole statement in subselect, you have a 8 megabytes limitation for this join. If you have another join in outer select, you have another 8 megabytes. Yes. Yes. So what happens if this join size, if you use regular join, and this table is bigger than 8 megabytes, and so this throws an you receive an error that the table is too big to join, and so the good practice, I'm not sure if it's good or bad, but so the way to if you don't know the real size of the data. The good practice is just try to use a regular join, and if it fails, try a join each, because this one has a performance penalty. Or if you don't really care about the performance, you might always use join each to avoid the error. Clear? What is the error we get if the size limitation exceeded? I think it's something like the table size is bigger than. Yes, it's not like error code 1 2 3 4 5. Yeah. Yeah, so actually there are some requests like that if we are not really sure in advance. But however, at this point, we don't have a way to tell. Oh, yes. Yes, on UI, yes, we do say. Okay, so the group by. So the group by also have similar restriction about the size of the groups or the number of the groups. Okay, before I jump into that, the fields in group by must be in select. That means that means you can't do select A or select some A from blah 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 group by B, because the B is not declared in select statement. So in the select statement, it may not be directly B. It can be you can just pass the B to the function. But in any case, that group by field must be specified in select. And large group by. So if you have so many categories or so many different values in group by field, it still fails. And we can still use group each by in the same way as we join. Repeated field. So we talked a lot about the repeated field. And BigQuery automatically flattens the data for repeated field when you select. So, so in this example, so this is a little complicated example, but we have a kind, full name, age, gender, and phone number, area code number, and the children. This person can have multiple children, and each child has name, gender, age, and cities you live. This is also repeated. And this nested field is also repeated. Anyways, so in this field, so if you select, that includes one of the repeated fields, it's automatically flattened. So that means it's like if you have a one row that have one value with a repeated field, it behaves as if it's two rows. If you have two values, you have it behaves as if you have two rows with the same value for the non-repeated field, and each repeated field has different values. However, what happens if we have multiple repeated fields like this? You have children and city lived, and you want to have a query that includes both values, one from children, one from city lived. Who has a child whose name is George, and whoever lived in New York? So in this case, actually, it's not flattened by default. So, but we still have a way to do that. So we can, when you select the table, we can explicitly flatten this table by the repeated field name. So as in my previous example, if you have two repeated fields, you flatten for the one of them first, and then the other one is flattened automatically. Oh, yes. I think you get an unexpected result, or the result is not what you mean, I think. Let me come back to you later.
So if my entire table had one row, and then my child field had two values, if I said select child from table,
You get two rows, yes. So the question is, if a table has one row with and that row has two children, and if you select child's name, you're gonna get two results, two rows as a result. Right. Oh, so in this case, so in this case, if you don't flatten, so if you flatten explicitly, when we process it, it's already flattened, so it's not automatically, it's not considered as automatic expansion. Mm-hmm. Yes. No, no. So this has an assumption that you include only one repeated fields in your query. So in this example, if you say we have multiple children, which is a repeated field, but we also have multiple cities you ever lived. But if you query for your full name and child's name, who has a parent's name is Mary with a child name is also Mary, in that case, this repeated field doesn't have anything.
Okay, so an example where you need to use flatten it for this particular example is if you want to find out all the people who live in Singapore and have children below 3 years old. So because you're asking for cities, which is a repeated field as well, a repeated field, and the children is repeated field. So you're actually querying multiple repeated fields. So in that case, you will need to use flatten. I think. Can you repeat the question again? No, you will. So the idea of well, okay, I don't know if the idea of flatten is, let's use an example, right? So if just use again this example again. So my name is Wally, right? So I have 4 children. So in the database I would have Wally as one single record here, and my 4 children's name would be here, right? So if I say select my name and children's name, so the query will automatically flatten it. So you can think of it as my name. My oldest daughter's name, Carissa, is that Wally, Kaylin, Wally, Katarina, and Wally, Colin, right? So that's the process of flattening it. So it's kind of like a denormalization.
Thank you. Yeah. Was that clear? Yes. Both of Yes. So the question is if we use two fields from 2 repeated different fields. So in this example, if we query by children and city lived. So for example, we want to pick up family or the parents whose child is Mary, named Mary, and the parents ever lived in Singapore, for example. So in that case, we include 2. So the 2 field comes from repeated field. So in such case, we don't flatten everything automatically. So we use either one in a flatten, and the other one is automatically flattened. So for example, if you use children to flatten this one, when the BigQuery process your query, your original data is already flattened by children. So if Wally has 4 children, you have 4 Wallys in your table already. And then you can query by city. I think you can specify a multiple more than one fields. Actually, I'm not sure. Wally, do you know how we can flatten multiple? Or do we do flatten here as well?
Can you have another select within this table, such table and flatten? Assume I want to flatten. So basically, conceptually, right?
Right.
I think conceptually, if you look at this statement here, so what flatten is giving you is kind of like a denormalization process, right? So it did not denormalize the table for you. So if you say, okay, select ... from flatten table, repeated field, comma, flatten, blah, blah, blah. So basically, it's just a kind of like you're running a select from 2 different tables, right? So it's kind of select from table A, table B in that case.
But in the usual case, I would need a cross product. So assume in a real scenario where you have multiple repeated repeated fields. Actually, the idea is creating all the combinations of repetitions. If you have them flatten one and then flatten the other.
So can we do from flatten parenthesis table with field 1, parenthesis close, then another for the second close.
If they are listed, then you can create the cross product.
No, I mean, what I mean is, yes, first flatten by first field, and then flatten. So you have an external function to flatten first, and then flatten with another field.
So will that return the same result? Will that return the same result as that?
Yes, that's true. Yeah? Shouldn't it? We'll check it later. Check it now.
Okay, the one of the problem with the repeated field is if you decide to use a third-party tools, right? A lot of standard tools like Tableau, those visualization tools, you can do drag and drop, and those assume standard SQL. So if you have something like nested record, it won't work with a lot of existing tools. So in that case, then you basically have to write your own SQL. So that's why a lot of people tend not to use nested fields. So.
Right, thank you. Okay. So actually, we will have one more thing about nested record. So within record for repeated field has an aggregation for the repeated nested field. So if we do select full name and count of children names within record, this returns a count of the children for this person. So in this case, Wally will get 2. Wally will get 4, and I get 2. Windows function. This is also a little complicated one. So calculate over the groups of rows. For example, the ranking per group. That means, suppose we have a table about the, say, scores of the common test among high schools. So each person have his score and his high school. So and we can rank we can have a global ranking. But if we use this window function, we can know the ranking in the same high school. So this person is the first one in his high school, and the other person is also first rank 1 for another high school. So here is a Windows function example. So this rank function is a ranking for each group of the data. So if we do by partition, by corpus order, by word count, we have a ranking. Ranking by word count, partition by this corpus name.
I added this slide last minute. That's why Shiro is completely new to me. So I think the easiest way to think of the window function is kind of like you run a normal query, right? So you get a resource set, and the window functions allows you to apply a function to your resource set. Just think of it that way. I think that's the easiest way to remember to think of it. So for this example here, so the data itself is coming from the Shakespeare public data set. So in in the Shakespeare public data set, so basically you have a word and the frequency of the number of occurrence of that word in corpus basically is his writing. So in this case, Shakespeare's wrote Othello, right? And so what I'm interested in is, okay, count all the words that appear in his work Othello, and rank it. So if you just do a regular select word count order by descending, right? So you will see 29 times the word handkerchief was mentioned 29 times, right? 29, 5, 4, 4, 3. So what you do is, okay, now I want to apply a rank function here. So over this, right? So you say, okay, this 29 is 1, 2, 3. So 4 is a tie, so 3, 3, 5. So think of it as that way, right? So the example that he mentioned, like if you have multiple high school, you can actually see which individual rank in his high school. So if you change this select statement, if you remove, because in this select statement, I'm just in the where the condition, I basically filter out all other Shakespeare's work, and I'm just including the Othello. So if I remove this corpus, this condition from the where clause, and if you run this this query, what you would, and then add the corpus here, what you would see the result set would be like the word handkerchief, the word count, and then corpus Othello and Othello in this run 2, 3, 4, right? And then you will see all his other works, and you will see the ranking. So you can try this actually. So if you have BigQuery up, you can just run it, remove this one, add your corpus here, and you will see the result. So I think that's the easiest to. Oh, the petition you always want to petition by the corpus, right? So because you basically what the petition, think of the petition this way, right? So now you have again. You run your regular select statement, you have the result set, right? So now you want to rank it, but how do you rank it, right? So you say, okay, I want to, in my example, I want to petition the ranking by the corpus. So in his example, I want to petition the result set by the high school. So once I do the petition, then I apply the ranking function to each petition. Is that clear?
Well, one question is, why does Othello use so many handkerchiefs?
Because Shakespeare's work makes you cry a lot.
Okay, so I think I was right if I was when I was wondering if I had this slide. Right, regular expressions. So actually, this is my favorite one. So I think the regular expression, how many people are familiar with the regular expression? Well, quite a lot. So actually, this is very powerful because this enables you to analyze the unstructured data. So the SQL and BigQuery basically handles the structured data. But if we use this regular expression, you can still do somewhat analysis for the unstructured data. If you have say free text comment or some arbitrary text documents, you can use this regular expression to do more research. And what's amazing is it still finishes in realistic time frame, like seconds or minutes, over the huge data. Back reference. So the question is, how do we support the back reference? Yes. So we can use a regex replace, and we can. No, we can not directory. Oh, not directory. Yes, but so probably we can walk around by using this regular expression replace with something else, so that you can refer in the external regular expression.
can I nest the regex, for example, replace? For example, can the original string be another regex replace, or I need to have them in a nested query?
Or you can replace, you can nest this function.
So it could be like regex replace, and then the original can be another regex replace.
Yes, correct. Okay, so the first part is done. Go to BigQuery to advanced queries. And maybe we will have 10, 15 minutes